Hi, I'm Lance Foster. I'm an engineer at NASA, and welcome to the NASA Engineering Design Challenge, Parachuting onto Mars. Have you ever traveled in a car and suddenly had to stop? Now imagine you're in a spacecraft traveling 13,000 miles per hour and you only have 7 minutes to slow down and safely land your vehicle on the surface of a planet, such as Mars. To do this, you first have to understand the concept of drag and the effect it has on an object traveling through space. Drag is a force that opposes an object's motion through air. For example, as a spacecraft like this one accelerates, the surrounding air pushes against it, creating resistance. However, to slow the vehicle down enough to make a safe landing, a decelerator or drag device serves as a braking system for the vehicle. That's the challenge NASA faces every time it lands a spacecraft on another planet. And as we plan more advanced robotic missions and human expeditions to planets further out into our solar system, we'll need to land even heavier spacecraft. This will require more powerful, yet lightweight decelerators or braking systems. Next up is NASA engineer Chris Tanner from the Jet Propulsion Laboratory to tell us more about a challenge that NASA has for you.
Hi, my name is Chris Tanner, and I'm a mechanical engineer at the Jet Propulsion Laboratory. Here, I do wind tunnel testing of parachutes for eventual use at Mars. NASA's been traveling to Mars for over 40 years, and with every spacecraft we send bigger, heavier, and more complex robots. However, the heavier the spacecraft, the more difficult it becomes to slow down once it gets to Mars. Now, when a spacecraft lands on Mars, it only has 7 minutes to decelerate or slow down from 13,000 miles per hour to 0 miles per hour. Now, that's really hard to do. Up until now, we used a variety of different systems to decelerate our spacecraft, from airbags to retro rockets to supersonic parachutes. However, we're going to need something bigger and better to eventually land larger robots or humans on Mars. NASA is currently working on new, lightweight decelerator systems to help us slow down more quickly. One component of that is called a Supersonic Inflatable Aerodynamic Decelerator, or SIAD for short. This device inflates around the entry vehicle at high supersonic speeds, about 4 times the speed of sound, making the vehicle larger, creating more drag, and helping it slow down even quicker. Another component of the system is a larger and higher performance parachute. Now, previously, the largest parachute ever flown on Mars measured 71 feet in diameter and was used to land the Curiosity rover in August of 2012. Our new parachute measures 100 feet in diameter, which is about the same size as a big rig truck that you'd see on the road. This new parachute will also fly around Mach 2. Now, can you imagine a big rig truck flying at 2 times the speed of sound? These are the kind of problems that we work on here at the Jet Propulsion Laboratory. Now, your challenge today is to design a decelerator system to slow down your spacecraft. Now, there's a lot to take into consideration. In particular, how do you make your decelerator both large to create a lot of drag and also lightweight so it doesn't weigh down your spacecraft? Now, start thinking about what special features you want to use on your system. And we can't wait to see what the suggestions you have for our next trip to Mars.
Thanks, Chris. Now here's your assignment. Design and build a drag device that will help slow down and safely land your spacecraft. Each of your teams must design and build a drag device that is made only from the materials provided, must connect to a team-built cargo bay that is assembled using the template provided in the student journal section, has an overall mass of 50 grams or less, must have angled around edges. One large circle is not allowed, and protects the cargo bay when the spacecraft is dropped from a height of 1, 2, and 3 meters. Use the engineering design process to help you create a solution. Keep in mind, your design may not work as expected. You may have to perform multiple tests and make adjustments, but that's okay. It's all part of the engineering design process. Now, it's your turn to get to work. And by all means, be creative. I'm excited to see the designs that your teams create. Good luck.